Hi, so in this video I'll be breaking down 3 main scenes from my major work and evaluating the skills and problem solving that went into them. At the end I will additionally discuss export options I tested when rendering my final project. Essentially, for one of the scenes I wanted to see if I could replace the sky of the cinematic, and I knew that I'd need a depth map to do this. So I got the 2 versions and I added levels to my depth map. As you can see, this levels effect allows me to change the depth of the actual cinematic. Essentially, what you can do with the depth map is set your normal layer to Luma inverted matte. This acts as a mask and makes only the blackish and greyish parts visible, eliminating the white. So therefore, to do sky replacement, I knew I had to make the sky white and the foreground black. I messed around with the input black and white values until I achieved this. Then, when I did the Luma inverted matte, it replaced only the sky. I noticed that the edges were really sharp and harsh, so to fix this I added a blur which smoothed my edges out, making the whole thing look better. So for creating my texture, I decided that the best thing to start out with was fractal noise, which already creates a nice little texture. As you can see, I added some color correction. I just kind of messed around with the colors until I found something that I really liked. To make the colors more prominent and bright, I added a deep glow, which did exactly that. At this point I thought the texture looked cool, but it didn't really match the cinematic. It just kind of looked out of place to me. Now I could have added some effects and colors to the 2D environment to max the texture in the background, but instead I went a completely different direction. I added some chromatic glow which completely changed the whole feel and look of the texture, and I think matched the 2D environment a little bit more. I still felt like the texture didn't quite fit, so I decided to reduce the saturation to match the 2D cinematic a little better. To make my 3D model in Element 3D, I could either use text, a mask, or a .obj file from a 3D animation program. Since my idea wasn't too complex, I decided to mask my design. As a result, I had a 3D object that reflected my mask, which I could extrude along the Z-axis. So now that I'd created my 3D object, I had to actually track it to the cinematic to make it look a part of the scene. I could have done this with the inbuilt After Effects 3D camera tracker, but I chose to use another process called Cinematics Buddy, because it's a lot more reliable and just consistent. Basically, what Cinematics Buddy does is it records a 3D version of your camera path, allowing you to track 3D objects to it. So as you can see here, I just had to run a script file for After Effects and then select the .text file which contained the information for the camera path, giving me my 3D space. After lining up the 3D version of my cinematic to the 2D version and messing with the speed and time remapping of the clip, I started to position my 3D object to where I wanted it in my 2D cinematic. I ran into the problem of my 3D object struggling to find its place in the 2D cinematic. For example, halfway through the cinematic, it would just be in a completely different place. But I was able to overcome this with a bunch of trial and error when messing with the positioning values. I then added some early effects, such as a color matcher which has the goal of matching the color of the surrounding environment to the object, and also some ray effects. After this I added another depth map and made the background black, but I wasn't too happy with the color of the cinematic, so I messed with the color and added some blue highlights and shadows to create a more nighttime feel. I wanted the 2 external handles of the object to move outward for the animation effect, but I could only move the object as a whole. So after doing some research, I found that within the Element 3D interface you could actually assign different groups to different parts of the object, which allowed me to move and keyframe the position of each individual part, solving my problem. Next I had to make the ball look like it was passing through the object. And to do this I had to put the ball in front of the first half of the object and behind the last half of the object. Initially it was only behind it, so my first thought was to import a green screen layer of the ball, but this would put it only in front of it. I ended up having to manually mask the ball behind the last half of the object, creating that pass-through effect. Out of the whole production, this was the most time-consuming process, as I wanted the masking to be precise, and I had to do it for each frame. It took me about 1 to 2 hours. I felt like my 3D object needed something more, so I started to mess around with different effects, finally coming to this edge glow effect. After watching it back a couple times, I still felt like the scene was missing something. So I added some similar effects to the ball and keyframed it so that they were active when passing through the object. After this modification, I felt like my scene was complete, and I was satisfied with what I had made. The next thing I wanted to create was a seamless transition, where essentially 2 clips are meshed together into one scene. To do this, I knew I needed both clips to be recorded on the same camera path, so I opened both replay files inside of Rocket League to try and do this. Essentially the problem I ran into was this. Just say the first clip started 1 minute into the game. I would record a dolly path that started at that time. Now just say the second clip started 4 minutes into the game. If I loaded that dolly path from the first clip into my new one, it would start at the wrong time. To work around this, I had to take note of the starting time of my second clip and convert it from seconds to frames by multiplying it by 30. In this example, 5 minutes and 18 seconds, or 318 seconds, equals 9,540 frames. The reason for this conversion is because Rocket League is a 30-tick game, and frames are the units the dollypath file uses as its information for time. Then I opened my dollypath file and found the difference between my new starting frame and my old starting frame, then added this difference to each snapshot of the dollypath. This converted all of my snapshots to the correct time. I then used the depth map to isolate the foreground and mask out the background. This allowed me to superimpose the second clip on top of the first clip and blend them together into one scene. When exporting the final version of my major work, I tested 3 different frame rates, which were 24, 30, and 60 FPS. I decided to go with 30 FPS because I think it looked the most cinematic out of them all.